Welcome to the second lecture of Module 3 of the course called Game Theory and Economics. Before we start this lecture, let me just take you through what we have covered in this module so far in the first lecture. We have been discussing the application of game theory and application of Nash equilibrium in particular in various situations. So, we have started out with the application of Nash equilibrium in case of markets, in oligopoly markets, and this market that we are discussing right now is called the Cornot model. So, in Cornot model, the number of firms that there are in the market, they are not a large number of firms. However, the number of firms is not one also. So, it is a few number of firms are there, and that is called an oligopoly market. What these firms are doing is that they are trying to maximize their profits, and the decision variables, that is the variables that they are choosing are their respective output levels. So, by choosing their output levels, they are trying to maximize their profit. Now, the point is that how is the price determined in such market? What happens is that after all the firms have chosen their quantities, that is the output levels, they are sold to the market, and if they have to be sold, then the price has to be of a certain amount, and that price will guarantee that all the goods produced by the firms are getting sold. It is not that the amount that they are producing is more than what the consumers are demanding, because there is another side to the market which is formed by the consumers. So, the price in the market is determined where the demand is just equal to the supply. So, that is how price is determined. Price is not determined by the producers, it is determined by the market condition at the point where demand is equal to supply. So, that is the story, more or less the basic story. We have started out with how to apply the concept of Nash equilibrium in such a market. We said that for the time being, let us take a simple case where there are two firms only, and these two firms face the demand function in the market given by Q is equal to alpha minus P if P is less than equal to alpha is equal to 0 if P is greater than alpha. And this is the direct demand function, and from this we can get the inverse demand function, which is this and this. So, these are the inverse demand functions. What about the cost function of the producers? We have assumed that cost of a producer is given by the unit cost is small q small p multiplied by qi, and this is for both the firms. So, both the firms have the same unit cost of production. From this we have tried to find out what are the best response functions, because in Nash equilibrium one way to find out the Nash equilibrium is to try to find the best response functions, and from the best response functions what is the Nash equilibrium, because one property that we have seen before is that at the point where the best response functions intersect with each other, that is also the point of Nash equilibrium. So, here also we are going to do the same. We are going to find the best response functions and try to find the point of intersection. And in the last lecture, that is what we have been doing. We have found that the best response function of firm 1 is Q1 alpha minus c minus q2 divided by 2 if q2 is less than equal to alpha minus c is equal to 0 if q2 is strictly greater than alpha minus c. This is what we have seen before, and by applying the same method that this we got by maximizing the profit function of firm 1. We got this function, this best response function of firm 1. Similarly, if we maximize firm 2's best profit function, which will be again a function of q1 and q2, we can get with respect to q2, we can get the best response function of player 2, that is firm 2. It will be given by q2 if and so these two are the best response functions of player 1 and player 2, that is firm 1 and firm 2. What is the Nash equilibrium? So, Nash equilibrium will be given by that point where these two functions intersect. Can we represent these two functions in terms of diagram? It turns out that we can. Suppose we draw this diagram. And we want to draw the best response function of firm 1, suppose. Now, firm 1's best response function is given by now and is equal to 0 if q2 is greater than alpha minus c. So, let us suppose this is alpha minus c and this is also alpha minus c, and this is suppose alpha minus c divided by 2. If q2 is greater than alpha minus c, q2 is less than alpha minus c, then this becomes operative, this becomes operative. And how does this look like? If q2 is equal to 0, q1 is equal to alpha minus c divided by 2, which means this function, this curve is going to start from here, and we can see that it is a straight line curve. It is not a quadratic or a function of higher order. So, the diagrammatic representation will be a straight line. If q2 is equal to 0, q1 is equal to alpha minus c divided by 2. If q1 is equal to 0, then q2 is equal to alpha minus c, which means this point on q2 axis and this point on the q1 axis are 2 points on the best response function. So, I can join them. So, this is B1. So, this part is for q2 less than equal to alpha minus c. If q2 is greater than alpha minus c, then q1 is 0, which means we are talking about the axis itself, q2 axis itself. So, this is my B1. So, it consists of two parts. One is the downward sloping part, which is after alpha minus c, and another is vertical part, which is over the point alpha minus c. What about the representation of 2 is equal to P2, which is a function of Q1. So, let us first write it down. So, again this is a straight line, and what are the points on the straight line? If Q1 is equal to 0, then Q2 is equal to alpha minus C divided by 2, which means this point is on the curve or on the best response function. If Q2 is equal to 0, then Q1 is equal to alpha minus C. So, this point is again on the function, best response function. So, I can join them, and if Q1 is greater than alpha minus C, then Q2 is equal to 0, which means that I am getting this axis itself, the horizontal axis itself, which means that this B2 is cutting this B1 at only one point. This is the point. This is the point of intersection. Let us call it Q1 star, Q2 star. Q1 star, Q2 star is the Nash equilibrium, because that is the point of intersection. But we have to find out what is the value of Q1 star and Q2 star. We have to find out the coordinates. So, to do that we have to solve these two equations. One is Q1 star is equal to alpha minus C minus Q2 star divided by 2. The other is Q2 star these two functions we have to these two equations we have to solve simultaneously, and if we do that, then what we get is the following. So, this is 3 divided by 4, which means Q1 star is equal to alpha minus C divided by 3, which means Q2 star which is nothing but 1/3 of alpha minus C. So, both these output levels, that is Nash equilibrium output levels, alpha minus C divided by 3 alpha minus C divided by 3. They are producing the same level of output, and which is not surprising because their cost functions are same and they are facing the same demand function. So, there is no difference between these two firms conditions. That is why in equilibrium they are producing the same level of output. What is the total output? Suppose Q star is the total market output in equilibrium. So, this is Q1 star plus Q2 star, which means 2 divided by 3 alpha minus C, and price, the equilibrium price, price formula is that it is alpha minus Q. So, alpha minus Q alpha plus 2C. And what about the profit? Equilibrium profit. It is given by, suppose Q1 star. So, this profits will be the same because they are producing the same level of output. It is given by the price in equilibrium, or we can use the result that we had derived before, the profit function, which is Q star minus multiplied by alpha minus C minus Q2 star minus Q1 star square. So, this was the profit function that we have derived before. So, it will be, I can take Q1 star common. So, alpha minus C minus Q1 minus Q2, and what is alpha? This is alpha minus C divided by 3, alpha minus C minus 2 by 3 alpha minus C, because there are 2 alpha minus C's. So, this is nothing but alpha minus C divided by 3. So, this is alpha minus C whole square divided by 9. So, this is the equilibrium profit of each firm. Now, remember when we started out with this analysis of Cornot equilibrium, we said what are the main purposes of studying Cornot equilibrium or any market for example. We want to find out what is the equilibrium quantity and price, that we have found out. But what we get from here is what will be the effects of various parameters on the equilibrium price and output. For example, suppose in the market demand conditions improve, demand curve shifts to the right. What is meant by demand curve shifting to the right? I can show it in terms of diagram. So, demand function is given, the inverse demand function is given by this. This is for Q less than alpha. Now, so demand curve is given by this downward sloping line. When demand curve shifts to the right, that means this intercept is rising. And what is the intercept? Intercept is alpha. So, alpha rising means that demand is rising, all right. So, this alpha parameter captures the position of the demand curve. If consumers are willing to buy more goods, that will be represented in terms of rising rise in alpha. So, can we look at how alpha is affecting each of these equilibrium variables? And the answer is yes. We have the following results, that Q1 star is equal to Q2 star is equal to 1 by 3 alpha minus C. P star is given by alpha plus 2 C divided by 3, and the profit, equilibrium profit, is given by alpha minus C divided by 9, this whole square, and capital Q square star, that is total output, is alpha minus C multiplied by 2 divided by 3. Now, this we know. So, it means that if alpha rises, all these variables, all these equilibrium variables, that is Q1 star, Q2 star, capital Q star, P star, profit, that is pi star, everything is going to rise. Why this is happening is that if people are trying to buy more goods, demand is rising, then all the firms will start producing more good, which means Q1 star and Q2 star will rise in equilibrium, which will push up the total market output, which is capital Q star, that will rise. And what will be the effect on price? Well, price, we see that P star is increasing in alpha, which means that if more demand is generated in the market, price is going to rise, which is not very surprising. If people are ready to pay more in the market, the price are likely to rise. And profit earned by the firms, that also shows improvement, because pi 1 star and pi 2 star are rising in alpha. So, all these things are rising. What about C, the effect of C? Now, C is a representation of the unit cost of production. Now, C depends on technology used by a firm, because why I am saying this? Because as technology improves, the cost of production, the unit cost of production of that firm goes down. So, C goes down as technology improves. Now, how does that affect each of these variables? We can see that as C declines, Q1 Q, let us call it Qi star, that improves, because Qi star is a declining function of C. What about P star? P star declines, pi I star rises, Q star rises. And again the rationale is not difficult to find. As technology improves, the firms are ready to produce, are able to produce goods at a cheaper rate. They can produce goods at lesser cost. If they produce goods at a lesser cost, they are going to produce more, because the profit margin, the profit that is can be obtained by producing one more good, one more unit of output, that is high. In that case, they are going to produce more, that is why Qi star is rising. P is declining, that is profit, equilibrium price in the market is declining, and this is happening because the firms are ready to produce goods at a higher quantity, because their cost has gone down, and since in the market more supplies has been created without any change in demand, because alpha is remaining constant here, price goes down, that is why P star has gone down. The overall effect on profit is positive, which means that the firms are earning high profits now than they were earning before, because the cost of production has gone down. So, that is why Pi star has gone up. So, these are the basic lessons that we can draw from this skeletal framework that we have so far constructed. Now, we can talk about some applications or further extensions of the model that we have just seen, because if we remember that this model is a very elementary kind of model. It assumes that the cost of production of both the firms are the same. Now, in real life that is not the case. The firms may be using different technologies. So, their unit cost of production, this we had assumed to be CQI, but it may happen that instead of this it can be like this. If that is the case, if cost of production differs across firms, does the same result that we have seen before hold? The answer is no, and that is what we are going to investigate in the next illustration. Suppose two firms are there like before, just to keep the story simple. The demand function as before is a simple linear function, that is the inverse demand function alpha minus q, and 0 alpha is greater than q, alpha is less than q. But here the cost functions are such that the unit cost of production is different for different firms, and let us suppose C1 is greater than C2, and also alpha is greater than C1, because we have seen that alpha has to be greater than the cost of production, otherwise the firms may not produce anything, and C2 is greater than 0. So, the cost is positive and the unit cost differs for firm 1 and firm 2. In this case, what is the equilibrium? And more particularly, suppose if this is the case, then which firm produces more output in equilibrium? So, Q1 star is greater than Q2 star, or Q2 star greater than Q1 star, or equal. We had the case of equality before. Now, will that remain same, or now it will change? So, this is what we are going to investigate. Also, we are investigate, suppose Q2, which is already less than Q1, falls, then what is the effect? What effect on equilibrium output, for example, and price, how the price is going to change, or total output. So, these are some of the questions that we are going to answer in this little bit more realistic case where the cost of production might differ. So, like before, the way to approach this problem is not going to be different from what we have already done. So, we are going to maximize this function, profit function of firm 1, and if we do that, then what we are maximizing is the following. we are maximizing Q1 alpha minus C1 minus Q1 minus Q2. This is what we are maximizing. So, if we do that, then with respect to Q1, and then with the result that we shall get is, this is going to be maximized at Q1 equal to alpha minus C1 divided by 2 if what we have done is just instead of C, which was the common cost of production before, we are writing C1. And similarly, this is the best response function. Q2, that is the best response function of firm 2, will be alpha minus C2 minus Q1 divided by 2 if Q1 is less than equal to alpha minus C, equal to 0 if so. These are the best response function, and let us see what is the equilibrium in terms of a diagram. So, if I have to draw firm 1's best response function, it is this B1, and this intercept is alpha minus C1. What about firm 2's best response function? It is going to be something like this, where this intercept is alpha minus C2. Now, intentionally I have drawn this intercept alpha minus C2 to be higher than alpha minus C1. The reason is that C2 is less than C1, which means minus C2 is going to be greater than minus C1, which means alpha minus C2 is greater than alpha minus C1. So, this intercept on the horizontal axis is higher than the intercept on the vertical axis, and if that is the case, then obviously from the from this illustration itself, it is found that in equilibrium, that is at the point of intersection, Q1 star is going to be less than Q2 star. So, this is one result which we can at least gauge from this diagram, but is that true mathematically? That we can verify. Why? Because we know that the equilibrium can be found out by solving these two equations. If we solve these two equations simultaneously, we get the Nash equilibrium, and solving them we get the following, that Q1 is equal to alpha minus C1 divided by 2 minus half of alpha minus C2 So, this is the equilibrium quantity for firm 1. If I can substitute this q 1 into the best response function of firm 2, and I can get q 2 equal to alpha minus 2 C 2 plus C 1. So, these are the equilibrium quantities. From this, can I say that q 1 star less than q 2 star? Well, we can say that. For why? Because we know that C 2 is less than C 1, which means minus C 2 is greater than minus C 1, which means minus 2 C 2 is going to be greater than minus 2 C 1. So, alpha minus 2 C 2 is going to be greater than and which is going to be greater than alpha minus right, because what I am doing is that just replacing C 1 by C 2, and I know C 2 is less than C 1. So, this must be true. So, which means that q 1's q 2 star, this is q 2 star, is greater than q 1 star. So, that is what we have found, that in equilibrium the firm which has a lower cost of production, unit cost of production, is going to produce a high level of output than the other firm which has a high cost of production. What happens now? This is the case where the firm's best response functions are intersecting at a particular point, but remember, this is not necessarily the case. This situation will occur, of intersection will occur in a particular condition, and that condition is that alpha minus C 1 is greater than alpha minus C 2 divided by 2. That is, this part is higher than this part. This higher, the bigger part is alpha minus C 1, and this smaller part is alpha minus C 2 divided by 2. So, only if this is true, we are going to have this Nash equilibrium of 1/3 of only then we are going to have this Nash equilibrium. If alpha minus C 1 and equal is less than equal to alpha minus C 2 divided by 2, then what is the equilibrium? So, then we are going to have a corner solution here, or so it is going to look like this. So, these are the points of equilibrium then on the vertical axis. Then the Nash equilibrium we are going to have is 0 and the only firm 2 will produce. But how much will the firm 2 produce? Firm 2 will produce the amount which is given by its intercept, its vertical intercept, this intercept. And what is that vertical intercept? It is just alpha minus C2 divided by 2. So, in all these cases, the Nash equilibrium, in the Nash equilibrium, the firm 1 is not producing, the firm 2 becomes the monopolist, that is, it is the only producer in the market, and the amount of output it produces is given by alpha minus C2 divided by 2. So, this is what is the situation if this condition is satisfied. If this condition is satisfied, both the firms are producing output. Now, what about the second part of the question? If C2 declines, what is the effect on Q1 star, Q2 star? How do they behave? Now, we know that if we are having this case, the second case, let us call it case 2, if C2 declines further, then C1 remains same, does not change because it is already 0. What about Q2 star? As C2 declines further, then this value is going to rise. So, Q2 rises as C2 declines. In case 1, as C2 declines, we can see that this is going to fall and this is going to rise. So, as C2 declines, Q1 star falls, Q2 star rises. So, these are the effects on individual output. What about the price? So, let us look at what will be the price in equilibrium in case 1. In case 1, the price is given by alpha minus Q1 star plus Q2 star, and this is alpha minus, I can take 1 by 3 common, I do not have to do any further. From there we can find out what happens if C2 declines. If C2 declines now, then the effect of C2 on P is going to be positive, that is P is going to rise. And the reason is the following, that as cost of production of firm 2 goes down, firm 2 produces more output, and as a result price starts to rise. But hold on. Firm 2 produces less output, firm 1 produces less output, firm 2 produces more output, and the net effect is that in the market the price is going to rise. What about the effect on Q total output? It is nothing but the summation of individual outputs, which means it is 1/3 of which means that if C2 declines, then Q star is going to rise. So, I was wrong about this effect on P, that is price, equilibrium price. As Q star rises, what happens to price? Price is alpha minus Q. If if this Q is rising, so it means that the price is declining as C2 is declining. So, that is how it turns out. In case 2, where only firm 2 produces, and the production is alpha minus C2 divided by 2, and Q1 star is 0. The price, the quantity is obviously alpha minus C2 divided by 2. What about the price? Price is this much. So, here as C2 falls, Q2 star is rising, Q1 star is unchanged, capital Q star, that is total output, is going to rise, and P is going to decline as C2 is going to fall. So, the effect is like before, that as cost of production of the firm 1 goes or firm 2 goes down, that is the firm which was the more efficient firm. Firm 2 was the more efficient firm, its C2 was less than C1, that is the cost of production of firm 1. As cost of production of firm 2 declines, firstly in equilibrium firm 2 produces more output, that is irrespective of the case where firm 1 was in fact producing some output in equilibrium, that is irrespective of that. Firm 2 always produces more output if its cost of production declines. As a result, total output tends to rise, and as total output tends to rise, total the market price, that tends to fall. So, this is the overall conclusion of this model where cost of production differs. And what is basically happening here is, one may ask that if firm 2 is producing more output because its cost of production is declining, why is it the case that firm 1 is producing less output? Well, the answer is that as firm 2 is producing more output, in the market the supply is going up. As the supply is going up in the market, the price is going down, and as the price is going down, the firm 1 is getting more and more discouraged to produce any output. So, that is why Q1 star is going down when C2 is declining. So, that is basically the logic which is in operation here. So, this is the crux of the Cornot model. How one firm behaves, how much output one firm produces, that affects the other firm's production level. The logic is this: if one firm produces more output, in the market the supply rises. If the supply rises, then the market clearing price will have to go down, and if the market clearing price goes down, then the other firm finds it difficult to sustain the same level of output. It then cuts down its output, and this is exactly what is happening. If the more efficient firm, that is firm 2, is producing more output because cost of production has gone down, the first firm is getting shut out from the market, and we have seen that in case 2, that is this case, firm 1 is producing nothing. And remember this condition, What this condition is basically saying is the following. This is alpha minus C1 is, this can be alternatively written as so this condition translates to this, that 2 C1 is greater than equal to alpha plus C2, which means that relative to C1, C2 is very little, it's a small value, which means that the cost of production of firm 2 has become so less. Alternatively, the cost of production of firm 1 has become so high that firm 1 is not finding it profitable to produce in the market, only firm 2 is producing in the market. So, that is the logic of it all. Now, one more interesting property of Cornot equilibrium is that it is a case of prisoner's dilemma. We are going to show that in terms of an illustration. Suppose that instead of competing with each other, these two firms collude. What it means is that these two firms, instead of fixing their output separately and trying to maximize their individual profit, taking the quantity of the other firm to be given, suppose they decide that let us meet together and let us decide what the total output in the market is going to be, what is the total supply in the market going to be, because we have the control over the total supply in the market. So, let us decide what is the total supply in the market going to be, which is going to maximize the total profit, and once the total profit is maximized, we can divide that total profit equally. So, that can be an alternative way instead of fighting with each other. Now, so that is called a collusion. Which means that the firms are taking their decision united in a united fashion. So, what happens then? So, what the firms are deciding now is to maximize, how to maximize, that is pi 1 plus pi 2, the total profit, let us call it pi, that is what they are maximizing. Now, what is pi 1 plus pi 2? It is Q1 P minus C Q1. We are retaining the old assumptions, that is the unit cost of production of both the firms is equal, and we have this simple linear demand function. So, profit, the total profit, the united profit is, let us call Q1 plus Q2 as capital Q. Now, so what the firms will now do is to maximize pi with respect to capital Q, instead of bothering about individual profits and maximizing the individual profits with respect to the small q's. And if it does so, what we get is the following. This is alpha minus q multiplied by Q minus this, and what is the solution? Alpha minus Q, this is the first order condition, minus Q minus C is equal to 0, which means that 2Q is equal to alpha minus C, capital Q is equal to alpha minus C divided by 2. So, this is the first order condition. We can check that the second order conditions will be satisfied, because if I differentiate this with respect to Q once more, I get minus 2, which is negative. So, the second order condition is satisfied. So, this is going to be the total output if the firms decide to maximize their joint profit, their united profit. So, individual output level will be half of this. What about individual profit? Individual profit will be half of the total profit, right? Half of total profit. What is the total profit here? Total profit is PQ minus CQ, which is so this is the total profit, which means that the individual profit, that is, it is going to be half of that, which means alpha minus C whole square divided by 8. So, this is let us stop here. So, this is the case where the firms unitedly decide how much they will produce, and we have seen that the output they are going to produce is alpha minus C divided by 2, and the profits that they earn is alpha minus C whole square divided by 8. Before we finish, just to recapitulate what we have done. We have basically discussed the various aspects of Cornot equilibrium, Cornot oligopoly model. We have seen that in equilibrium the firms produce the same level of output, and if one of the firms is more efficient, then that firm produces more output than the other firm, which is not very surprising. And if that firms become too much efficient, then the other firm may be out of the market. This more efficient firm becomes the monopolist, and we are in the process of discussing what happens if the firms decide their output levels in a united fashion. So, we shall pick up the thread from here in the next lecture. Thank you. First question: if there is an exogenous rise in demand for goods, what are the effects on individual output, profit and market price in Cornot equilibrium, and what is the rationale? Now, to understand this, let us recall what is the equilibrium in the Cornot model. So, if we have the standard assumption that linear demand curve and constant unit cost, then we know that individual price is going to individual quantity is going to be alpha minus C divided by 3. The equilibrium price is going to be 1/3 of alpha plus 2C, and profit is going to be individual profit alpha minus C whole square divided by 9. Now, if there is an exogenous rise in demand, This basically means alpha is going up, because demand function, if you remember, was QD is equal to alpha minus P. So, alpha rising means the demand curve is shifting upwards. Now, we can see that as alpha rises, Q1 star is going to rise, P star is going to rise, pi I star is going to rise. And what is the reason why is it happening? What is the rationale? Well, as alpha rises, there is an exogenous shock, upward shock on the demand. People are ready to buy more. If they are ready to buy more, obviously in the market price is going to rise. And as price is rising, the firms find that their profits are rising. And when the profits are rising, they are going to respond by raising quantity, the amount of output that they produce. That is why Qi star rises as a result. How change in production technology affects equilibrium variables? What is the rationale? So, this is a similar question. Production technology. How is it reflected in this particular model? Now, if production technology becomes more improved, if it improves, then if then simplistically, very simplistically, we can say that the cost of production is going to come down. Cost of production, which is small c, is going to decline. So, this change in technology is basically manifesting itself in terms of change in C. Now, how does it affect our variables? Let us again recall what is the quantum of each of the variables. So, this is how the variables look like. Now, unlike before, here if C declines, then the effect on each of these variables is not in the same direction. As C declines, we can see that P star is going to decline. As cost of production declines, each of the firms find it easy to reduce the price a little bit. And it is not the case that they are controlling the prices, but what is actually happening is that as the cost of production declining, then they want to produce more, okay? Because it is possible for them to profitably produce more when the cost is declining, to maximize the profit. So, basically what is happening is that Qi star is going to rise, and that rise in Qi star is basically raising the total supply in the market and reducing the price in the market, and pi I star is rising because cost is declining. Okay, that is the intuition. Thank you.